Welcome to my presentation. In this presentation, we shall see the proof of product rule followed by some examples. So let us say, let a function y be a product of two functions, f of x times g of x. Let f of x be a function, let g of x be another function. If we want to find the derivative of product of two functions of this type, we should be able to do it as follows. We apply the derivative formula of limits the way we know it, and let me write that here. Dy by dx is equal to the limit as h approaches 0. Let me rewrite this. As h approaches 0 is f of x plus h minus f of x, this whole thing divided by h. And then substituting the given function into the formula, we can write this as follows. Dy by dx is equal to limit as h approaches 0. We can write this one as follows. F of x plus h times g of x plus h, like that. We'll put that in parentheses or brackets, minus f of x times g of x, and I'm going to put this in a set of brackets like that. This whole thing divided by h, like that. Now we will add and subtract f of x plus h times g of x, so it does not change the given equation, but by combining and finding the common, we should be able to find the derivative of the given function. So I'm going to add and subtract f of x plus h times g of x to this whole function. So let me write that here. So this is going to be equal to limit as h approaches 0, f of x plus h times g of x plus h minus, I'm going to write the one which we're going to add and subtract in another color, f of x plus h times g of x, like that. And then I'm going to add the same function, f of x plus h times g of x, like that, minus, the rest of the function is this, minus f of x times g of x. And this whole thing, I'm going to put a bracket here, this whole thing is divided by h, and I'm going to close the bracket here. So now if I were to look at this expression which I have just written, and if I were to say, if I want to combine f of x plus h, I'm going to put this in another color, and then if I were to say f of x plus h times g of x in this green bracket here, and then combine it with f of x plus h times g of x, and then close this green bracket there, and then open this green bracket here, f of x plus h times g of x minus f of x minus g of x, and then close it here. This will be one part of the numerator, and this will be the other part of the numerator, and therefore taking f of x plus h common in the first set of the brackets and taking g of x common in the second set of brackets, we have we can rewrite the above expression as follows. So we can rewrite this one as follows. So limit as h approaches 0, f of x plus h, if I pull that out common, we are left with g of x plus h minus g of x, like that, close brackets, plus, if I pull out g of x common in the second set of brackets, g of x, like that, g of x, open brackets, f of x plus h, let me rewrite this, f of x plus h minus f of x, this whole thing divided by h, like that. So close brackets. Now we can, when we look at this expression, we see that we can write this one as follows. We can write this one as follows. Limit as h approaches 0, we can write this one as f of x plus h times g of x plus h, g of x plus h minus g of x, close brackets, this whole thing divided by h, like that, close brackets, plus limit as h approaches 0, open brackets, g of x times f of x plus h minus f of x, this whole thing divided by h, like that, and then close brackets that way. Okay, now as we can see from here, as f of x plus h, as h tends to 0, like let me write here, as h tends to approaches 0, f of x, f of let me rewrite this, f of x plus h tends to f of x. And then same thing in here, as h tends to 0 or h approaches 0, g of x approaches g of x. Same thing, there doesn't change anything there. So therefore, in here, if we were to look at this, this f of x plus h, as h approaches 0, this changes to f of x, like that, and then this whole expression here, the limit as g of x plus h minus g of x, the whole thing divided by h, this expression here, this is nothing but g prime of x, like that. And then in the second part here, plus this part, g of x is same as g of x, nothing changes there. And then this part of the expression, limit as h approaches 0, f of x plus h minus f of x divided by h, this part of the expression, this is nothing but the derivative of the function f of x. So therefore, we can come back and then write this out as follows. dy by dx is going to be equal to the first function, which is f of x, times the derivative of the second function plus the second function, g of x, times the derivative of the first function. So this is our proof of the product rule. We can state it in terms of words as the first function, the derivative times the first function times the derivative of the second function plus the second function times the derivative of the first function. So this is how we can show the proof of the product rule. In my next presentation, we shall see examples using the product rule.